All right. It's my pleasure to welcome everyone to the Infinite Games Workshop. And today we are going to have Andreas Tsevas give us a talk. He's from Munich in physics, but he's going to give a talk on a finite position with game value omega squared, which is a result that I find extremely interesting. And I spent a long time trying to do this myself and with my co-author, Corey Evans, to try to find such a position. We had positions with value omega and omega plus n and so on, but omega times n even. But it was hard to get a position with value omega squared. We couldn't ever quite do it. And I think that looking at what Andreas has done, the reason why we couldn't do it is that we just were looking only at simple positions instead of extremely complicated positions with thousands and thousands of pieces, which is what I understand his position will be like. And so evidently that's what it takes to prove this really incredible and beautiful result. So I'm really excited to hear Andreas talk about it. And so go ahead, Andreas.
Oh, yes, thank you for the introduction. So hello everyone. I am going to share my screen and show you the position and what I have done. But yes, more or less, I think the best way to sum it up is that was taking the sledgehammer approach to solving the problem and going for using many, many pieces instead of something like small or elegant. But okay, I'll start with before I should get into the position, I will first motivate it a little bit and give an ever so brief introduction into what was before and what was actually the inspiration with the look of how also to extend this. So the talk of my title is finite position infinite chess with game value omega squared, maybe plus some finite number. So first, to get into it, I will very briefly mention the infinite chess rules as they are used now in literature. We play the game on the integer lattice z squared. The short-range pieces, namely pawns, kings, and knights, move exactly the same way like in standard chess. But because we don't have a bottom edge or a top edge of the board, we don't have the concepts of pawn promotion, double pawn moves, or castling in the absence of a natural starting position. There are, of course, the long-range pieces, which make the game very interesting, namely queens, bishops, and rooks, which move like normally in chess in their respective directions, but can move any arbitrary finite amount in any direction. They are not blocked by another piece. The checkmate and stalemate rules, which determine the end of a game, work exactly like in finite chess. If a side has its king threatened and cannot get out of check, then that's checkmate. So that is a thing that, especially with finite pieces, is very simple to check, despite the fact that the game tree is infinitely branching. It's computable even. And now as for draw rules, usually the threefold repetition rule and the 50 move rule are omitted in the sense that we see them as a natural on the infinite board because they are just shorthands for the more general rule, the idealized rule of defining infinite play as a draw. So especially also my position and everything I will show you neglect assumes that the 50 move rule doesn't exist, else this would not work. This would be drawn. And now, of course, having these rules, one could just make a starting position like this and start playing. But we are more interested now in doing math than in actually playing like the specific starting position. So to get into it, let's talk a bit about game values, or intuitively, which is what I'm interested in here, which intuitively just characterizes the concept of distance to checkmate. And the one important observation that motivates this entire approach is that since infinite play is defined as a draw, where player winning by checkmate always has to occur at a finite stage if it occurs. So, which immediately implies that infinite chess is an open game, which also, where for this class of games, it was proven by Gale and Stewart in the 50s that these games are always determined. So there is always either a winning strategy for one of the two players, or both players have a drawing strategy. And this allows one to define the concept of game values as it was done by Corey Evans and Joel David Hemkin specifically for the case of infinite chess. by looking at which this is here's their original definition. And game values are defined recursively by basically assigning ordinal numbers to the nodes of the game tree, with all nodes where white has already checkmated their opponent having the value 0. And then for a node, if it's y to move, then the game value is just +1 of the minimal value of any position that white can move to. Basically, white by moving perfectly, can just reduce the game value by 1 on each move. Whereas black if it's black to move in a position and black, all of the legal moves by black lead to positions having a game value, then the game value of that position is just the supremum of those game values. But of course, if black had moved a position that does not have a game value, then that is a position where white is not winning, which leads to the central observation that the winning positions are exactly those that have an ordinal game value, which motivates this entire approach of thinking of game values as capturing basically the depth of the game tree until checkmate under optimal play. And this is a neat generalization of the concept of mate in n, where we are not restricted to some finite n. And so the goal with which everyone started when this was first asked on Math Overflow is to find large game values. And from now on, I will also only restrict myself to finite positions, because they are very neat and that you can just write a finite list of pieces and everything is very nicely behaved and computable and the game tree is computable. So a very good start that is now, I think, about 10 years old. I don't know what the first ordinal valued position was that was found, but that is the one that was also shown in the paper by Corey Evans and Joel David Hampkins, Trans-Finite Game Values in Infinite Chess, which is I think the simplest possible position of a position that is winning for white, but with black to move, there is no upper bound to the number of moves that white needs to checkmate black. In this instance, the optimal play for black is to move his rook north as far as possible on the first move, and then the white will slowly checkmate black by slowly moving his queen and rook up until he sandwiches the black king against his own rook and checkmates him, which you could show with a brief chess analysis. But yeah, and then the question is, can we go further? And to that end, the omega 1 of chess was defined by Joel and Corey, which is the supremum of the game values of the winning finite piece positions in infinite chess. And it was shown in particular that that has to be a recursive, can be at most a Church-Kleene ordinal, because every game value with finitely many pieces has to be recursive. And so we will want to approach that upper bound somehow. And then now I will show a particularly nice position, because that was also the first inspiration for my own construction, was one that was made by Noam Elkis, who showed how to construct a position with a game value of omega times n with a neat construction recipe. And this particular position, it has a game value around omega times 3. And the basic idea of the position is that almost all pieces here are trapped and cannot move by black. And the winning strategy for white is to get his knight on the top left and slowly move him towards the black king in order to capture that specific pawn and checkmate the black king. And all the other pieces by black and white should rather not move. Which is not immediately obvious from looking at that position, but you can read that analysis on Math Overflow. The important thing is that here the transfinite game value comes from the fact that black has a free black rook, which, while it is probably powerless to stop the white knight, if it is not, then you can just replace the single white knight with several ones. It has a lot of freedom to start checking the white king from the right. And the entire idea of this complicated looking construction is that these black rooks here, they separate the game board into two halves that cannot be where the white king cannot cross that row. Because you may see here that all these rooks are pinned to their own king, they cannot move. and the bishops need to stay where they are in order to keep up the pin. And the white king, when he's checked by the black rook from the right, then he cannot cross that barrier here of the blue squares. And so in practice, what this game will look like is with black to move. He will, for example, make his first announcement of moving, for instance, here the black rook 5 to the right. Then white will slowly advance towards his checkmate plans. And then black can slowly start checking the white king. And the white king, being powerless to stop the checks in any other way, needs to slowly crawl towards the black rook until the black rook cannot make checks anymore, and then can move an arbitrary distance again to the right, which gives white time to just go towards checkmate with his knight by one move, and so on. And this continues for as many, and this entire game continues for as many times that white has to move his knight in order to checkmate black, which basically shows you the construction recipe. If you want to have, for example, omega times 500, then just put an army of white knights around 500 squares to the left, such that they need 500 moves to checkmate black. And I am mentioning now this position in such detail because this was the basic idea that also gave me the inspiration. If someone is confused, please ask me questions. But I remember reading a particular comment on Math Overflow, which said, yes, this is very nice having omega times n, but in order to actually make this an omega squared position, the black would need some mechanism to force the white knight as far as he wants in the very beginning, because then black would have a mechanism of choosing how many moves white actually needs to checkmate him with his critical piece. And then, of course, the game continues with black rook checking white from afar. But no one was able to do this for a long time, and I think it's very hard to do with a knight. So my idea at some point is there some other white piece that we can lure away, that black can lure away as far as possible in the beginning, and then force him to just slowly advance towards checkmate with that piece while his king is subjected to repeated checks. And that was the entire inspiration for my position, which I will show shortly, which is gives me a family of positions such that for every natural number k, I can construct a position with 1,477 pieces, such that it has game value omega squared plus k, which in particular proves that the omega 1 of chess is at least omega squared plus omega. And now, yes, the specific position that fulfills this is this one, consisting of 5 components that contain these 1,477 pieces. And as I mentioned, the basic idea is again exactly the same. The white king is just chased around continuously by a black rook who can give him checks, forcing the white king to approach him. And the only free piece that white has in the entire position that can freely move around the board is a queen. And the entire idea is that in the very beginning, in the very first move, black is able to lure away the white queen as far to the left as he wishes. And then the white queen, in order to deliver checkmate, cannot just go straight back. It will be forced to bounce around very slowly between these two horizontal lines. Going back to the position. And only when here it is near this position, it will be able to deliver checkmate. With the caveat that the black rook has the freedom of checking the white king an arbitrary number of moves every 2 queen moves. So in effect, by the initial choice of how far black lures away the white queen in the very beginning, he makes the choice of how often the white queen will need to bounce around between these 2 critical horizontal lines. Every 2 bounces correspond to 1 decision by black to checkmate white as many times as he wishes. So while the position may look quite imposing at first, in effect, we mostly need to analyze just the moves of the black rook and the white queen, which are the only 2 entirely free long-range pieces that move into the position. And all the other pieces will be neatly contained in their respective compartments, which we will, of course, now have a look. So now let's start with just looking at the components and what they actually do. The most important component here is component A, which is the king fortress in the center of the position. Okay, so let's have a look at it. The king fortress contains the black king in the middle, who is basically completely boxed in and surrounded by his own pieces that are also boxed in and pinned and completely unable to move. Here on the left, you can ignore for now. Here the pawns on the left, they are just the right-hand side of the component to the left of that. First of all, what's important is that the only free moving pieces here in this component are the white king and the black rook. And you can also notice that here on the bottom, there is a black pawn that is free to move, but that only exists in order to prevent stalemate ideas. Other than that, it has no purpose. It is just... Okay, so first of all, you can notice again that we are utilizing the idea of having black rooks, again, that limit the freedom of movement of the white king, with in particular here having two white bishops that pin black rooks to their own king, thus creating this barrier again of these two blue lines, which basically force the white king to stay on the top right quadrant in the entire game. And with the top right quadrant being completely devoid of pieces, other those you can see here, that means that the white king has nowhere to hide on the top right quadrant if he is ever put to check. Now all of the piece of the black, all of the queens you see here and the bishops are completely boxed in. They cannot move. And we can have a more close look later in particular, but also here the white bishops also have nowhere to go and have no movement of freedom. And now the important feature you may notice are these numbers here on the left, which are basically the mechanism with which white will hopefully checkmate black if possible. So
question?
Yes.
Could you explain why? I'm sure it's true that white doesn't want to actually capture the pinned rooks with the bishops, but could you explain why that would be?
Yes. So maybe let's have a look here. For instance, if yeah, okay, let's make a move. For instance, for the bottom rook, it's very obvious because then immediately that would free here an army of black queens, and in particular, for instance, black can also capture him like this, which would also free the pin. And basically, the only idea that, which I will come to, that white has to checkmate black is to capture this black pawn to the left of the black king, because white is at a massive material disadvantage in the entire position. Also, when we look at the other components, and if black just manages to release once his hordes of pieces, then he will immediately have many queens that will in particular be able to, at worst for white, just keep perpetually checking his king on the top right quadrant. Also, yes, so this vulnerable pawn here will be critical. But in particular, also if this rook is captured, then black can just recapture it with this rook, immediately destroying any hopes of white to checkmate the black king here. But when we see the other components, it will be, I think, more apparent how black is at a massive material advantage. And his only actual plan is capturing this critical pawn marked in red here. Here at this point, it's good to count tempos, because counting tempos is very important. The only pathway white has with his single white queen to checkmate black is to go through this winding corridor on the left of the black king. And now, assuming here we have this corridor and here this entrance diagonal where white can enter in order to deliver the checkmate. Now, assuming the white queen is here on the square marked by X at the entrance of this corridor, then let's see how white will checkmate the black king. On his first move, he can move here. then 2, then he can move to square 3, then 4, then 5, then 6, and then on the 7th move he can capture that vulnerable black pawn, delivering checkmate to the black king. Where here the number 7, so assuming the white queen is on the square marked with X, the number 7 is very crucial, so keep that in mind for now. And we will return later to this component and see why it's actually boxed in. But for now, keeping that number in mind, let's have a look at component B, which is which is the queen initialization component. And also it acts as the northern barrier because it is exactly north of this entrance corridor that white needs in order to checkmate the black king. Now, if we take a closer look, again, all the pieces here are completely boxed in, and it just contains a white queen and a black queen, with black to move. But you can notice that despite black just initially having a black queen, that black queen has no escape. It cannot go anywhere at all. So no matter where it goes or what it captures, immediately white ends up having another queen. Even if I hope you see the position. Even if the black queen captures the white queen, then it will just be immediately recaptured with a pawn, and white will end up having a free queen again. So after the first move, black will in fact lose his queen, and white will end up having a queen, and black can do nothing about that. And later, the best plan for black will be to move his black queen as far to the left as possible in order to lure this white queen out. But okay, let's continue with the other components first. Now to the south of this corridor, which is the entrance to the king fortress, we have the southern barrier, which blocks the corridor, which completely blocks the corridor, the vertical corridor from the south. And here I call it a time bomb because it mostly acts as a failsafe for white. Now taking a closer look, again, you see that this position here on the top is again boxed in, nothing can move. The only freely moving piece here is this single white pawn. And if now just assuming that nothing else happens in the position, then white can just ever so slowly move up his free white pawn 1 square at a time. There is really no way to accelerate this for white from the outside at all, until he reaches the black pawn here and captures it, and then start moving his pawn column up 1 square at a time. And then after around 30 moves, white will be rewarded by releasing a second white queen, which is just a very, very slow mechanism, much slower than all other threats will be in the position, that if white for some reason ever gains 30 tempi, then he will have a second white queen. But basically this component only exists for the single purpose to make sure that if black trades his rook for the white queen, then black has no more free moving pieces that can actually do anything on the board. But neither has white, but then white will win because he can slowly release his white queen. So this mostly acts as a mechanism to prevent black from ever trading his rook for the white queen. Okay, and now let's have a look at the most critical and complicated, I promise, component of the position, which is here component D, for queen and knight formation, as I call it, which basically makes sure that the white has to bounce between these two critical horizontal lines with his queen. Okay, now let's have a look at what is going on here. It's
Excuse me, Andreas.
yes.
When you say trading the black rook for the white queen, the black rook, the one in section A, right? The one that is
yes, exactly.
King. Okay.
Yes, exactly. So from now, when I always talk about black rook or white queen, I always mean just this black rook here, or the free moving white queen, because these are, as I said, the only entirely free moving pieces in the position.
Yeah,
all other here black rooks or whatever are just stationary. See. Yes. Okay. Yes. So now let's take a look at component D. First of all, you can see again, everything is completely boxed in here in this component, and nothing can move except for this white knight in orange, which can only bounce around these two orange squares. Everywhere else it moves, it will immediately be captured. And now, first of all, the important, what you may notice is that here on the right-hand side of this component, there are many trapped black queens. And black would, of course, like to free these black queens. And it would be very nice if his rook could somehow infiltrate the component, capture the white pawns that are blocking the release of the white queens, and go on to win the game, or at worst, perpetual check the white king, who is helpless in his top right quadrant. And now just to count some tempos again and see how this would be done. Let's assume, for instance, that the black rook starts somewhere on the top right quadrant, somewhere far away. Let's say here. Then how would he actually release his queens? On his first move, he would move into here one of these columns that either from the top or from the bottom that stare down these incursion squares that are marked in red. And you can see that the only squares to enter the component here from the top or from the bottom are these incursion squares marked in red. Then on the second move, he would go to such an incursion square. On the third move, he would capture the white pawn. On the fourth move, he would move away again. Then black needs 2 moves to push 2 black pawns out of the way, such that on his 7th move, for instance, he can move this queen out into this column. Then on the 8th move, he can move it here onto such a release diagonal. And then on the 9th move, he can move it successfully out of the component in order to check the white king. Is this clear, or should I show this also on the chessboard with actual piece moves? Okay. So so as I said, here the important fact is that here the black rook on the top right or bottom right needs 9 moves in order to release a black queen. And now the question is, of course, what can white do against this threat? You can see that this white knight can actually guard here the incursion squares in the center, incursion square number 2 and number 3. And these 2 critical horizontal lines where the white queen will turn out to bounce around guards all the other incursion squares. Here incursion square 1 and 1 beta on top, and 4 and 4 beta on bottom. So for instance, if the black rook is on top here, then the white queen being here and the white knight being here can completely guard that threat. And then where the white rook and the black rook, can no longer make an incursion from the top and would have to try from the bottom again. Which, yes. So let's leave it for now at that with this component. And now it is time for the first important observation with tempi. As I said, the black rook being here somewhere on the top right, for instance, is a threat of a perpetual check and 9 moves. Because on the 9th move, if white does nothing, the black queen will be released and start checking the helpless white king. But now let's yes.
Could you just explain a little more slowly? Who is it that's threatening to come in and do those moves 1, 2, 3, 4, like you said? Is that the free black rook that's over there? I thought that was the rook that's just harassing the king. Or so the queen is guarding these 2 rows and has to move back and forth because there's threats on the other one. But who is it that's making those threats? Which piece is it?
I guess it's exactly the black rook. Basically, it serves 2 functions. It's both the black rook that is harassing the white king and the one making the threats. And we will see shortly how he can combine those 2 functions together.
But I see. But he's initially on. Okay, I see.
Yes,
okay, right, that's fine. Thanks.
Yes, yes, but yes, it's. Yes, basically, yes, we will have a closer look on how he can do it. But basically, now just assuming he starts somewhere in the top right, yes, then he can exactly make those moves I showed you, like move number 1, here 2. I hope you can see it. 3, 4, 5, 6, 7, 8, and then the 9th move is moving out. But yes, for now, it's mostly important just to keep in mind the tempos, the tempi.
So
And
in actual perfect play, that sequence will never happen though, right? Because the white queen is going to prevent that from even starting in the first place. Is that correct?
yes, exactly.
Okay.
Exactly. It's just the threat is important, and especially the tempo count is important. Because now, while keeping in mind that the black rook here somewhere in the top right has a threat that will facilitate the 9 moves.
Okay, so
now,
he can be very far away, and to make the threat just means to occupy that vertical line, perhaps very high up in the middle of his harassments. Is that correct?
Yes, exactly. So but if the black rook is already on, let me draw a somewhat straight line here, then that would actually correspond to a threat of perpetual check in 8 moves. But just by existing somewhere on the top right quadrant or on the bottom right quadrant, just by his existence, he's always threatening perpetual in 9 moves. Basically. And now the important thing is, Lau,
Also,
what is the... Yes?
I had a question. I just noticed that there were like 2 tiny pawns, one white one and one black one, to the west of section B. Was that like an accident, or do they also serve some sort of purpose?
They actually they are not blocking any of the important columns. They actually also serve a purpose, but we will see that much later.
Okay, thank you.
Oh, sorry. Can I ask a little question too? When you have the white king, is that I forget in these games, like do you have to have the white king, and are you using it for like game value purposes?
Yes, so here his existence and his roaming on the top right quadrant is critical to the entire mechanism. It's basically a standard chess rules. Every side has a king, and both sides need to prevent their king being captured. So they have to move him out of checks and prevent him from being checkmated. And here, that white king is basically the source of omega power in this case, because we will see how he will keep getting harassed and having to move. So this harassment of the white king will be very critical.
Andreas, may I have also a tiny question about
yes.
the southern section of the position? Are you gonna get back to that, or is it just symmetrical, the discussion around it?
Yes, it is completely symmetrical.
Right.
So
okay.
you can see again, you have the same here, like columns and the same incursion squares and also the same tempo count. But yeah, good question.
But because the black rook, because it was the white king that was fixed into that 1/4, the northeast quadrant of the board, but the black rook could also go from below, even though it wastes his moves.
We will get to that. Basically, there is a mecha. Basically, component. The last component will take care of that. Will be a way for the black rook to switch between the top and the bottom of the board. But yes, good observation. Yes, so while component D is like for all our purposes like symmetrical top to bottom, the entire position, of course, is not. But we will get to that. For now, let's so focus on the tempo count again. Let's say that the white queen is somewhere here on the left of on one of these 2 horizontal lines where she's guarding a threat. Then what is the actual checkmate threat that white makes? Remember, the only way for white to checkmate the black king is to reach this corridor to the left of the king fortress, and to reach here a square on the entrance diagonal marked with X. But the fastest way the white queen can do that from the far left is to reach this square marked with X in 3 moves. For example, by moving like this, which are 3 queen moves. Or by moving like this. Because the critical feature is that the northern and the southern barrier actually block this corridor from the top and from the bottom, and they prevent an immediate queen move, for example, like this, just going diagonally and reaching that entrance corridor in 2 moves. And in total, because from that square marked with X, the white queen will checkmate the black king in 7 more moves. From this position here, the white queen just threatens checkmate in 10 moves. 3 moves to reach the entrance diagonal, and then 7 more moves to checkmate the black king. And now you can see, maybe already see why it is the existence of the barriers is very crucial, and also why it is very crucial for the white queen to go from the left to the right, because when the white queen has reached some small distance and is next here to the components, then she can dip between the barriers, and then she can reach that entrance diagonal in just 2 moves. So when she's actually near the rest of the position, the center of the board, then she has a checkmate threat in 9 moves. So then when the white queen has a checkmate threat in 9 moves with white to move and black just threatens perpetual in 9, then white is just in time to checkmate the black king, which basically explains how white is rewarded with his queen approach. Because yes, traveling along this horizontal line actually makes his threat to the white king, to the black king, just 1 tempo stronger. And these tempos are the crucial backbone of the entire logic of the position. But keeping these tempos in mind, let's just have a look at the final component of the position, component E, the bishop formation, which mostly acts as a switch to let the black rook cross from top to bottom and vice versa. And when you look into it, you have a trapped black queen on the bottom right of the position that currently cannot exit because the only square it can go to is guarded by a white pawn that is also guarded by a white bishop. So as of now, here black cannot do anything with this black queen. But that white bishop is quite vulnerable. It cannot exit the component, but the only squares it can move to are these 3 squares marked in green. And it can go nowhere else. If it stops on any of the blue squares, or if it goes anywhere else and sacrifices itself, it will be immediately captured. So the bishop will only ever move between these 3 squares. And when it is captured, for instance, that the black rook can try to take this white pawn, and the black queen will be released. And now we can count tempos again. So now this time, let's say that the black rook is somewhere here on the bottom, already threatening the white bishop. And now let's say that white does nothing, just ignores that and plays somewhere else. Then again, counting tempos. Then on his first move, black can capture the white bishop. On the second move, move out of the component again. On the third move, move to the right. Then on the fourth, move a bit up. On the fifth, capture this first white pawn. On the sixth move, capture this critical defending white pawn. And then on the 7th move, the white queen will be able to make just a single square move. On the 8th move, she will be able to go here, for instance, or to square 1 here, for instance. And on the 9th move, the black queen will be able to start perpetually checking the white king again. So once again, this time when the black rook is attacking, staring down the white bishop, black threatens a threat of perpetual and 9 moves again.
Wait, on move 7, when the queen just made a single square move,
yes,
wouldn't the black queen be able to take? Right? Or was I getting the pieces mixed up?
No, these are all moves by black. Maybe okay.
Oh,
maybe
right. I thought that there was the white queen moving around. My bad.
No, maybe let me show here on the board again. So we have the situation where here the black rook is already threatening the white bishop, and white does nothing. Then move number 1 is the black rook capturing the bishop. Move number 2 is this. Move number 3 would be something like this. Move number 4 here. Move number 5 capturing the white pawn. Move number 6 capturing the second white pawn. Move number 7, the queen moving here. Then move number 8 moving here or here. And then move number 9 is the beginning of the perpetual checks. So yeah, these are all moves by black.
Yeah, sorry, just one question about the perpetual checks. But so the black queen is checking the white king, right?
Yes.
Also, black could also use the rook, which you've just used to capture the pawn in red, and then actually capture the white king, or?
In principle, maybe. If the point is yes, one could imagine that. That's why I'm always saying at worst for black, he can start perpetually checking. But of course, the entire position is winning for white, and we will see how white will actually win. And of course, that's why he just wants to prevent this.
Okay, so this is not happening in perfect play. Okay, great, thanks.
Yes.
Right. So you're saying perpetual check, but actually it's a threat for black to mate. I mean, that's what David is saying, right?
Probably. I mean, if one could imagine.
If you have a free rook and a queen out there, I mean, you're not just going to make perpetual check. You're going to checkmate the king, aren't you?
That depends on how close. That depends, of course, on how close white is to checkmating black himself. Because now if you just assume that both of them just drop what they're doing and just go as fast as possible for white for the checkmate and black also for releasing his queens.
I see. Okay. All right.
Yeah, then welcome. Yeah, then white will basically have his queen just on the doorstep of the black king. But yes, here I'm just perpetual is basically a shorthand for black queen release and the start of checks, whatever happens then. Yes, okay, so with the basic components out of the way, here again with a large-scale overview, we can start with looking at what typical play looks like before analyzing like specific deviations and looking at the components more closely. And that's why here I made a little sketch or cartoon of the important squares that will be used during play. Here, the squares marked with a Q are just the ones that the white queen will ping pong on her way to go to the right, and then dip between the barriers. And the squares with the Greek letters are the squares that are important to the black rook. Here you can see here the beta and gamma squares staring down the positions where the white bishop can go, such that beta and beta prime look at the two left white bishop squares and gamma prime to the two right. Maybe if you look at component E again, you see how it looks like here closely. So here somewhere on top we have beta prime and beta and gamma prime. And the black rook can only cross that component actually from beta to gamma and not through the primes.
With the understanding that these are arbitrarily far away from component E, like the Greek letter positions.
Yes, exactly. That's why I'm stressing, which is actually very important, that this here is just a sketch. Because actually black would be very wise not to pick the square specifically like I put them here, because then he could be under, for example, like I drew it here, under direct fire from the white queen diagonally, which we want to, for example, of course, black doesn't want something like this, which he wants to prevent that. So basically this here is just drawn with understanding that the squares alpha, beta, gamma, and delta are very, very far away in their respective directions here on the up and down. And it will turn out, black would be best advised to choose these Greek lettered squares so far up vertically that his distance to the center of the board vertically is always at least twice the horizontal distance to the white queen, such that the white queen will never be able to interfere. So the sketch is mostly here just so that we can fit this in some finite space, if that makes sense with everyone.
So sorry, I have another question. So when the black rook goes to beta and threatens that bishop, then the white response will be to move the bishop to the beta prime column out of the way, and that's how black gets through to the gamma place, or how does it work exactly? I thought the whole point of that bishop thing was to allow the black rook to move from the alpha beta kind of lines at the top to the delta gamma lines on the bottom. Is that correct?
Yes, good. That's exactly what I will get to now.
Oh, I see.
Yes, to show how the pieces typically move. So here I made the important pieces large. So now let's assume after some finite gameplay, we have reached the position where the white queen is here on Q4. and the white knight is up, and they have just guarded all the incursion squares on the top. So the white knight is also on top, such as the black rook here on alpha, staring down the incursion squares, can currently make no threat in the component D, the left head component. And the white bishop is here on the left green square. Now, the black rook, because he can make no further threats on top, but he should really make, here in component D, but he should really make further threats because the clock is ticking and white has the way to release a second white queen. So now what he can do is he can threaten the white bishop in the right-hand component. And now, recalling our previous analysis, that is a threat of a perpetual in 9 moves. If white just does nothing. Whereas on the other hand, the white queen now just threatens checkmate in 10. So white is forced to move the bishop out of the way. We will look at deviations and what can happen otherwise in a bit. So now black again needs to make a threat and moves now to beta, threatening the white bishop again. Now the white bishop can move either to the left or to the right. If he moved to the left again, then that would just be a repetition of moves because the black rook can then just move to beta prime again and threaten him. But of course, white does not want to do that. White is winning. He does not want to have a repetition of moves. So he moves his bishop to the right, and he cannot immediately be threatened by black again. So the black rook has no option now on the top anymore, but moving through the component. And now the black rook is somewhere far down on the bottom right quadrant, and his existence down here threatens a perpetual 9 by infiltration of the incursion squares in component D, here on the left-hand side. Because he needs 2 moves to enter an incursion square, and then 7 more moves in order to have a black queen start checking the white king. So because there are several incursion squares and white cannot just guard them all in a single move, here, for instance, he's forced to move his queen now along to the bottom row, and he can do that in such a way that he moves his queen diagonally and it gets a tad bit closer to the center of the board. Now the black rook can threaten here the incursion squares, and white is just in time with moving his knight down to the bottom orange square in component D, so as to have guarded all the incursion squares just in time. And now black can repeat again. He cannot do anything on the bottom of the board anymore, so he threatens the white bishop. The white bishop has to move out of the way because that black's threat is still 1 tempo faster. He threatens again, perpetual in 9. The white bishop moves out of the way, and now the black rook moves to the top to square beta again, with the distinction that this vertical move can be as long as black desires, while of course it still has to be finite. Black can move his black rook to the top by any arbitrary distance he so wishes on the top quadrant. Of course, always keeping the constraints in mind that he has to move his rook at least a certain distance. Now he's threatening again a perpetual 9 in the component D. So the white queen has to move to the top horizontal row. The black rook here threatens the incursion squares again, and the white knight has just in time again stopped the threat. And so on. And now the black rook can, of course, threaten the bishop again, and so on. But of course, between these 2 moves, between now the black rook continuing to threaten the bishop and moving down again, he can now start checking the white king, who, as you recall, is here somewhere in the top right quadrant. And because the previous move that black did was arbitrarily long far up, I'm referring to this one, black has now an engine of checking the white king as many times as he so wishes from the top, until the with the white king having no chance, but just being forced to go toward the black rook 1 square at a time. So this justifies why through one such loop, the black rook looping to the bottom and then to the top again through the switch, threatening component D, can always, with one such pass and every 2 white queen moves, can make one choice of how from what distance he wants to start checking the white king, which is the justification for the total game value being at least omega squared. So if that is clear for everyone, I will now look at the main deviations and ways that, yes?
I have a question. Okay, so one way of sort of stopping the check harassment is for the king to chase the rook down, which is how that mechanism is used in a lot of other plays as well. But couldn't the white king also just try to run and hide around some of these other components instead? Like if the rook is 10 billion miles high and the king is only 1 mile high, then it might be easier to stop the harassment by running and hiding around one of these central areas than by chasing the rook down.
In principle, that could be the case, but that is the exact reason why we have these pinned black rooks here, with a white which the white king here is unable to cross here, these columns and these lines.
So
this
there's no hiding. Okay, I see.
Yes, exactly. Other than that, here to the top right of component A of the king fortress, there is nothing. It's just empty space, which both justifies why white cannot normally just escape with his king these rook checks, and why also just the release of a single black queen on an otherwise empty board or quadrant like this will always be like a perpetual forever.
Okay, I see. Okay, thank you very much.
Come. Yes. A good question. Okay, now that we see the main gameplay loop, of course, you must say there are so many pieces. Let's have a look at the ways that the players can deviate from that perfect strategy. And let's start by in what ways black can deviate.
Andreas,
yes?
can I just ask you, at some point you said that when the rook went arbitrarily high up, you had extra chance to harass the white king with the black rook, which is going vertically. Was that what you were saying?
Yes, so after he has gone vertically, so the black rook has just gone arbitrarily high up and is threatening now. First of all, he's threatening component D and the incursion squares, which needs an immediate answer from white, which white does. And now is the point of time, or now or in the next move would be the point of time where black now uses rook to just start checking the white king.
Right. I also the two rooks, of course, there are two different black rooks. So you're not with the one that you moved all the way up.
No, it's just one black rook. All this time, these are what is shown here in the sketch are the only relevant pieces. This is basically maybe okay. Yeah, so basically this black rook is a multi-purpose tool in this case. He's both the one making all the threats, but in doing all these threats, he can make every now and then these moves of arbitrary large distance.
Maybe there's confusion, if I could help. The point is that it's not shown in your diagram, but to make the harassment round, the rook might have to move, for example, significantly to the right, even also to where the king is, and then check, and the king chases him down, and then the rook comes back to beta prime or beta or alpha or whichever is the next threat that's being made after that harassment round. Is that right?
Yes.
Okay, that clarifies it. Okay, thanks.
Oh, okay. Thank you, Joel. Yes, so you can imagine, like, assuming the position here has already been initiated, a black rook moving here to the far up, and making threat in component D, forcing some white answer. And now, before this black rook actually goes to square alpha, as I've shown, it can now start checking the white king. And the white king will have no option but to slowly, while he's checked, like one move at a time, move towards the black rook. And when the black rook maybe has done this now 100 times, then he moves on to square alpha and then to beta, etc. So he's always like interrupting the sequence I showed you to start checking the black king, the white king.
Okay, great, thanks.
Right.
Wonderful, by the way.
Sorry?
Just wonderful construction. Yeah, I love it.
Can we review, say, like the first two moves of the construction? Like, how does the white queen get onto the two parallel diagonals in the first place?
Yes, we will. We will come to that now. Good question. That's exactly the first deviation here. Now let's see what are actually the moves that black can do with the beginning, which is the initialization of the position. And to that end, we need a closer look here at the pieces in the beginning again. So in the beginning, the black rook is just here, does not have like that many opportunities. He's just here he's not threatening a perpetual 9 anywhere. Neither in component E, because he's not threatening the bishop, nor in component D, because he cannot immediately move to threaten incursion square. So let's see what happens. Let's say, for example, that the black rook moves up in order to threaten here a perpetual 9 in component D. Then just sacrificing his queen here. Then white can simply capture the black queen with his pawn. And now the important feature is that the white queen is already staring down this critical corridor. So while black now with his rook threatens a perpetual 9 moves, white actually threatens checkmate in 8 moves, because he just needs a single move to reach here the entrance diagonal, and then 7 more moves to actually checkmate the black king. So just moving his rook in the beginning somewhere away to threaten a perpetual 9 is not an option for black, because then his queen is just captured by the pawn. Now, if he, for example, if he, with his queen, he captures the white queen, and white needs to capture back, then again, here now at this point, the black rook now at best for black threatens a perpetual in 10 moves, because he needs 1 move to either go to the side to threaten the bishop or to go up to threaten a perpetual in 9 somewhere. But the white queen just here just needs 2 moves in order to reach the entrance corridor. For instance, let's say black moves here to the side to threaten the white bishop. Then the white queen just needs 1 and then 2 moves to move down to the entrance corridor. So that is also not an option. That is again just 1 tempo too short. What are other things black can do? The same goes for just capturing here, sacrificing his queen somewhere. Again, then it's even worse. Then the white queen can just go here in a single tempo, then to the entrance diagonal, and then again it's checkmate in 9. And while black only has a perpetual in 10. So in fact, the only option that black has in the very beginning is to move his queen as far to the left as possible. And now at this point in time, while this here, of course, is a threat that white cannot ignore, because if white just moves here, for example, his queen or any other piece anywhere else, then here black will already have a free black queen that can immediately start checking the white king. So here it is pretty hopeless if white just ignores the black queen and to ever go for a checkmate with a single white queen. So that is what is going to happen in the very beginning of the game. The black queen will typically move to the far left, and then the white queen will follow it. At which point black maybe wants to give a check, okay, but at this point the white knight starts here on the bottom. So black is best advised to start by moving somewhere up here, call it like square beta prime, in order to threaten a perpetual 9 moves here in the left-hand component. At which point, from his position, the white queen again just threatens checkmate in 10, so she actually needs to move down onto this critical horizontal line, and then the position is initialized as we saw it previously. And yes, we will get to more details on that just now. So another way that black could deviate is to move a non-rook piece. So let's have a look at all the pieces in the position that black can move during normal gameplay. Other than his rook, he has what you may have this 1 pawn, which is pretty useless because it can only move 1 square at a time. In component D, black has this pawn and this pawn, which are also pretty useless. If black moves them, then he just forever blocks the usefulness of some of his incursion squares. So he's best advised not to do it. And the single other non-pawn piece besides the rook that black can move is this knight in component E that you may have noticed, which exists so as to take away useful squares from the white bishop. But all the moves that black had ever make with this knight are completely wasted. Because, for instance, if black moves his knight here to capture the pawn, he's immediately recaptured. And also, if he moves the knight here, he's immediately recaptured. And this just gives either with a bishop or with a pawn. And this just gives white the advantage of, at best, of just having here a safe square for the bishop. Just locally, and which is a pretty bad deal for black. But of course, typically that's not even the best response by white. The best response by white is, of course, to move his queen horizontally near the center of the position, because black just wasted the move. And now white probably threatens a faster checkmate. And finally, just analyzing the moves locally, if black moves his knight to this square, then even assuming that the white bishop was actually on the right all along and cannot recapture, that is just a complete waste of a move for black, because white can simply ignore this. Because every single other square that the white knight can move to is guarded by a white pawn, or it just goes back. So all in all, now wherever else the white knight goes, he will immediately be recaptured by a pawn. And that will actually be pretty fruitless or useless for black to do, which justifies why black can only move his rook. Okay, let's have a look at some further deviations for black. If, of course, black could deviate
Sorry,
by...
question about the previous. Yes. So, if that knight moved to a place that gave the bishop a sort of free, safe place, then wouldn't black want to do that? Because no, wait, no, I'm confused. I'm sorry. Oh, never mind. Yeah, okay, I've got it backwards. Okay, it's completely fine. Thank you. Sorry about that.
Oh, it's fine. But yes, basically, yeah, white wants to keep his bishop because he can keep defending that pawn. So now when this bishop in this position would be threatened from above or below, he can just move here instead, where he's completely safe. Yes. Okay, yeah, okay. The next deviation I was already discussed. Basically, black can blunder by choosing his squares to be not far away enough, which is, however, pretty stupid for black to do and can be easily avoided. It gives black no advantage. And now let's see at the various ways that black can misbehave with his rook. First of all, black could, for example, say, yeah, what if I just keep threatening the bishop in the right-hand component, in component E, and using, for example, the switch several times in a row. Then that will actually be a way for black to lose very, very fastly, because when he does that, then goes through the switch once and then goes through the switch again, then he will be on the same side as the white knight again. Because in the gameplay loop I showed you previously, white always responds by moving his queen first to the correct horizontal row, just advancing it like a few squares at a time, and then moving his knight when that incursion square is threatened. And if black just cuts short what is happening there and makes and tries to make the same perpetual align threat on the same side, then white basically just gets a free move and can move his queen horizontally to the right. Maybe it's most clear if I show it. So you can imagine okay, maybe I will show it in the presentation. So you can imagine here the black rook has just moved through the component, and now instead of threatening here the incursion square and forcing the knight to go down, he instead threatens the bishop again from the bottom and goes immediately to square beta again. Then that actually threat on the top is completely fruitless because the knight is still on the top. So as soon as the black rook now goes to square beta again, then white can just move his queen here to q1 and threaten checkmate in 9 moves. Okay, let's look at the next way that black can deviate. Yes, sorry. Yes, the next way black can deviate is in component D to threaten one of the secondary incursion squares, which are these squares that I marked here with a beta, which is which again is pretty useless for black because these are just inferior threats, and if the white queen is already guarding here the incursion squares 1 and 4, then the secondary incursion squares are also already guarded. So during normal gameplay, black will just never do that. Of course, black could also waste a move with his rook by moving his rook either to the far left or to the far right, maybe in the hope of infiltrating one of the critical components from the left or from the right. But for example, for this component, for component D, it's pretty clear that black cannot do that. Because if black ever wastes a rook move to the far left, first of all giving white a free move, and then again wasting a move in order to move onto one of the critical horizontal lines where the white queen is not on, then that's the only reason why these white pawns marked in blue exist. Then they can just move forward by one and block this critical horizontal line forever, which is pretty bad for black because he has just wasted 2 moves in order to make a non-threat, and the white queen has surely used the time in order to advance nearer to checkmate, and black is now nowhere near threatening a perpetual in 9 moves anymore. So, but of course, normally, under normal circumstances, white does not want to push these pawns marked in white because they do nothing for him but block the path of his own queen to the incursion, to defending the incursion squares. And the same also goes for the black rook moving to the far right without giving a check. That again is a very fruitless threat because black would need many moves, 2 moves to move his rook here to the right, then would need another move to capture here, and that can at worst simply be answered by the white bishop moving from the left to the center here, defending the pawn, which basically just has black having wasted 3 moves, making no threat at all. And the white queen, again, can use the time to checkmate faster. And finally, of course, black can make any other rook move. In particular, he can try to sacrifice his rook. And these are actually the moves that, when designing the position, took a long time to sort out. And basically, there is the requirement of the position being completely stable despite any potential black rook sacrifices. So let's have a look at the position here in greater detail again. And let's say that even if white does nothing, let's try to sacrifice the black rook somewhere. So the black rook goes here, sacrifice himself on this pawn. Then white can just recapture and black still cannot untangle his pieces. Or else, let's say the black rook goes here, white still ignores him and he captures this pawn. Then again, this is answered by white, giving black no chances. Now let's say that black wants to untangle the rook pins and go down here and threaten the bishop. In this case, then white can simply capture with a pawn, which black can, if he so wishes, recapture. And then he can move his pawns. But here it also ends, and this still has not given black the freedom to untangle his position. And of course, the same also goes for the bottom white bishop, which is situated exactly here so that it is completely impervious to attacks from the black rook. Even if he goes here, yeah, he's just captured. He tries this. The pin can never be broken. And the same also goes for any single other component of the position. There, except either me or any playtesters have made a mistake somewhere. No matter where the black rook tries to capture and sacrifice itself, this will never lead to black being able to free any pieces. Which is now, because there are a lot of pieces, impossible to go over in detail now, but everyone can do it for himself. But basically, this is just making sure that there is nowhere that the position can actually be untangled. It's similar to the position by Noam Elkis, where also you have to argue why the position cannot be untangled. That at worst, black can do nothing, or at least free nothing within 10 tempi. So also the queens here cannot be freed from below. Okay, so if we believe that, then we can now finally also have a look at the possible deviations by white, what white can do. And the most straightforward deviations are white just ignoring a threat by black. by basically, for example, pushing a pawn in his time bomb component to free his second white queen, or just moving his queen horizontally to the right, thinking, yes, I can just accelerate my checkmate threat ever so slightly. But the point is, as we saw, or as we discussed, that in this case, then black will just threaten a checkmate that is a tad faster. But what needs a tiny bit of more analysis is what happens if white now actively chooses to sacrifice a piece. So as for the black rook, again, we have to do a lot of careful analyzing and see now if the white queen is free to go anywhere. Can she actually free or untangle any of her pieces? Well, the knight can actually is actually completely boxed in by pawns other than the two squares he can move to. So anywhere he can go, at best, he can be immediately captured or ignored by black, which would be a pretty bad idea for him to do. And the white queen here also cannot free, for example, here the trapped white bishops anywhere. Okay, let's take the white queen and, for example, try to have her capture anywhere. It seems pretty hopeless. Or the white queen could try to free her trapped bishops here, but that also doesn't work. For example, any sacrifice here is immediately met by a counter capture. And also the white queen cannot enter here down any of these corridors because she will be immediately either ignored or captured. Now, also, we could have a look at what happens if white tries to sacrifice his bishop. For example, if the bishop is smart and tries to think, yes, I can go here, then of course it can be recaptured immediately, and the black rook that has just threatened it on the outside now threatens a perpetual in 7 moves by just going, not entering and exiting again, but just going to the right immediately. And now you could, of course, say, yes, but what if the white queen, after, for example, the black rook has done all this and has gone here and now is threatening to capture this pawn? What if the white queen, instead of abandoning her post and going for the checkmate, tries to defend the pawn instead of the bishop? Let's just, for argument's sake, let's grab the white queen and put it here. Then white could now try to push his pawns in component C, but now still the black rook could exit. The white queen is at this position 10 moves away from checkmating black, but now black can simply move up to square beta or down to square gamma and threaten a perpetual check that cannot, 9 moves that cannot be avoided anymore. So that also doesn't work. Okay, if we believe that, then we can look at some of the trickier deviations, which are basically all the nasty diagonal moves the white queen can make that have to be warranted at least some thought. So in the first diagonal move that the white queen can make that could, in theory, maybe have an impact is if she, after the black rook has reached square beta, for example, if she makes a diagonal move onto the alpha horizontal vertical column, such that the black rook cannot occupy it anymore. So this here is best to show with a sketch. Let's say the black, here the black rook has just here traveled up and is just standing here. Okay, let me mark this with an R. And the white queen, being on Q3, for example, thinks, yeah, okay, let's just go here to this square and prevent the black rook from actually going now here to his square alpha where he wants to go, being nasty. In that case, the black that is basically the sole reason why the secondary incursion squares exist, because then instead of going to alpha, he can just go scoot over 4 squares to the side to square alpha prime, if you so want to call it, and threaten the secondary incursion square, which you can see here. So imagine if the white queen is somewhere here on the top, then the black rook, being even more farther away on the top, much farther away, can just go here and threaten an entering here. And the white queen being here far away on the top just again only threatens checkmate in 10 moves or 9 moves at worst. But the black rook threatening the secondary incursion square here threatens perpetual check in 9 moves. So the best the white queen can do to defend this is she's unable to move, for example, to move back here into the component because this incursion square is actually guarded by a black pawn. So her only option is to actually take the long diagonal move, just take her last diagonal move back, just move back, having made no progress at all. And then the black rook, after the white queen has moved back here again, then he can threaten the primary incursion square again, forcing the knight to move up, and the play continues. So basically, white is only prolonging the game by 2 moves if he tries something like that, which the secondary incursion squares prevent. Okay, going on. Now white could also make a long diagonal queen move to protect his bishop in the right-hand side component in component E. But that is, again, basically disarmed by a repetition of moves. So imagine the bishop being here is threatened by the black rook. And then the queen being somewhere here thinks, okay, instead of letting my bishop die, I make a very, very long diagonal move to up here in order to defend it. Then the black rook just scoops back to square delta to threaten the other component again. And the white queen has no option but to move back again to where she came from, which basically also disarms this threat. And again, keeping in mind that the black rook has chosen his distance to be much, much farther away than anything the white queen can reach with 2 diagonal moves, it's completely safe from any direct attacks from the white queen. Yes, okay. Similarly, again, you could argue that if now during all his checks, for example, the black rook is somewhere here on the top and keeps checking the white king. For example, the queen being here could try to scoop in between and block the check if she is guarded by the white king. Then again, the black rook can just move back to square alpha and threaten component D, and the white queen has to move back diagonally. And as long as the black rook is significantly farther away, that is always possible. So basically just a repetition of moves of the last threat disarms all diagonal moves that the white queen can do. And yes, I think that's mostly it. And now I will finally answer the question why there are those 2 extra pawns there to the left of the queen initialization component. And that just exists because the very beginning of the game is special, because just in the very beginning of the game, the white queen is actually not on her 2 horizontal rows, but instead on this row where she's forced back. And now the point is that when the black rook now moves up in order to move to square alpha on the very next move, now the white queen can just for one single instance in the game, what she cannot do later, try to go back here to block basically the black rook from going to square alpha just this once. And she can actually reach the square here, which she cannot do later again. And now if I just use the normal tactic again of the black rook instead going here to threaten the secondary incursion square, then you could imagine the white queen just moving back down here diagonally and completely undo all the distance she was forced to do. And this diagonal move is basically completely prevented and forbidden by the existence of the 2 pawns that you can see in the position, which are these 2 pawns. So if let's say the queens move away and the black rook moves somewhere to the top, then actually the critical square that the white queen can move to is here, which is the square on top of this horizontal column. And now with the black rook, of course, being much, much farther away, threatens the secondary incursion square. And this here cannot be prevented by the white queen anymore, because she has nowhere to go where she could actually prevent this. So this just preventing the single move is the reason, and the start of the game is the reason why the white queen, why these pawns need to exist. Other than that, all the other diagonal threats again function in exactly the same way.
So why can't she move from that square down in and
Yes, that is again the same reason as before, that she could try to
into the mating maze there. Let's see. No, confused.
She could try, for example, you mean like here into the mating diagonal. Yes, because if she does that, then she's again just one tempo too slow. Because now she tries to do that, and now it's black to move, and black already staring down an incursion square threatens perpetual in 8 moves, and white standing here also just threatens checkmate in 8 moves. 1 move to here to the entrance of the corridor, and then 7 moves. So black is again faster having the move. But yes, actually, basically all these variants and deviations always hinge on that one fact, on the tempo difference. And yes, okay. And the final deviation one could imagine is that white moves his king in some weird way, either blundering a loss or trying to be tricky, because you saw that there are like here several black queen release diagonals. And now you could, of course, white should, when he actually goes for the checkmate, he should not have his king standing on one of these release diagonals or release columns. So if the black king was actually standing here and then black was successful in releasing his queen, then he could just, when he went here, check on his 8th move instead of his 9th, which is pretty bad, which white needs to avoid. But also now, of course, you could say that white could try to be tricky and stand just 1 square next to that release line in order to prevent the black queen from checking him on his 9th move. And that is why there is a certain redundancy in all the black queen release mechanisms, with the black queen in this case just being able to choose here another exit. And the same goes for having several distinct here release diagonals on the top of component D, which basically just gives a certain redundancy and makes sure that this perpetual 9 calculation always works out. Yes, and finally, there are some other like trickier deviations one could imagine. For example, after the white bishop has been threatened here or at any point, let me see, or at any point during the game, for example, try to be tricky and try to sacrifice himself on such a square. But again, here the tempo cow after he has been threatened by the black rook. So let's say, okay, let's reset this. The black rook here threatens the white bishop, and the white bishop sacrifices himself on the square where he's taken. But then again, here the tempo count works out exactly just right, because this time black needs again doesn't need to enter and exit that component. It needs 2 fewer tempi to actually start the perpetual check. So here he would need just 1, 2, 3, 4, 5, 6, 7, 8, 9, etc. So the tempo count works out to 9 exactly the same way. But of course, I do not claim like all these deviations I showed you now to be a very exhaustive list. And I can, especially towards the end of the game, where white is actually going for the checkmate, black could try many things, do different checks or sacrifice to prolong the inevitable by like 8 omega or something like that. But of course, no matter what he does, he will eventually lose in the end. Or white could try different ploys to, again, try to sacrifice his queen for the black rook. But the point is that typically there is always a built-in redundancy for black to repeat his last threat in order to prevent that. And yes. Okay, so maybe to sum up, should be the typical gameplay, and as long as this list of deviations is somewhat complete and we can believe that, then this first move that black can do actually corresponds to like a large omega squared announcement of how many omega announcement he wishes to make. And in particular, so the starting position has a game value of at least omega squared. So let's now determine the exact game value, because someone could notice that actually the exact game value of the position I've been showing you up to now is omega squared plus 1. Because in the very beginning, the black rook could, for instance, start to check the white king first, with him having to move, and just then the black queen moves out of the way to the very far left. And now if the white king takes the black rook instead of capturing the queen, then of course the black queen will initiate the perpetual checks here on the top right quadrant at worst for black. So having the position I showed you being omega squared plus 1, how do we increase this plus 1? And the way to do this is to simply add some finite value to the game value of the initial position by just starting off with a black rook as many squares as we wish to the right, which should not qualitatively change anything about the position. Because now if you just imagine the black rook, now this, what I'm making here is not a move, but just here with this being the initial position. Now, of course, black can start with checking the white king, and he has to scoot over first, which white cannot avoid. And again, now with his initial rook position, black is not threatening perpetual in 9, he's just threatening perpetual in 10, which is actually what we want for the tempo count to work out, so that white has time to capture the black queen. And actually, as long as white stays on the same 2 horizontal rows here, for instance, this will remain to be the case, and black will gain no advantage by doing these checks. So that is a pretty simple modification to have an omega squared plus k position, and the supremum of those being omega squared plus omega. Okay, so with that, I want to end my talk with before going to questions, with an outlook for, of course, the next step for any interested chess players or mathematicians would be to further construct interesting positions with larger game values than that, with finitely many pieces. And ideally, one would want to determine the omega 1 of chess with finitely many pieces and prove its value. And then, of course, the further interesting problems that may tie into that is the question of the decidability of infinite chess, and maybe how the 50-move rule factors into it, because a priori there is no reason why it should or shouldn't impact this entire discussion. So at least everything I showed you was without the 50-move rule. And maybe my key insight to sum up this entire discussion, which may have gone on a bit long, is that queens are actually very useful pieces, and in my view, the most useful pieces in order to achieve this entire thing. Because the entire construction hinges on just having a queen bounce back and forth between several pre-given lines. In my case, for example, a very broad sketch of the position is we have here some black box, and here 2 lines between which we have the queen bounce back and forth until the game concludes. But of course, while making this position, I just had this basic idea of try to have the queen bounce around between 2 lines. And I had some bad and some good ideas. So for example, having the queen bounce around like this, or have the queen bounce around like this, depending on different threats that are happening in this black box. Or you could imagine many different ways of having a queen bounce around like this, going around, or whatever you can imagine. And the queen was the only piece I was able to do this, because she is able to both be forced on a line while previously defending a different line, which is very hard, for example, to do with a rook or a bishop, because they can only move in one given direction. So when they move very far away, for example, you have a rook moving very far away here, and then you have him, for example, bounce around, between these 2 lines, then he's just bouncing around back and forth. You cannot do very much, or you cannot have him go around. And I found this to be the most important feature. I can imagine a position like this, or this idea maybe working without bishops or without knights, but I definitely cannot imagine working it without queens. So maybe that would be a good thing to keep in mind when making further such constructions. And now finally, I want to thank Naviary, I think, who is also here very much, because as you may have noticed, this entire time I was using the website he created to actually show and display the game. And one can actually also play the position there in single player or multiplayer. And that was actually very great and for playtesting and analyzing the position. And I'm very grateful for this tool here to exist for anyone to try this out, because previously the best replacement for something like this was a spreadsheet, which is not as satisfying to play in. And of course, I also find it very great and very satisfying that one can actually play infinite chess now on the internet with other people. Which, so while it may be a frivolity of the gods, as it has been called, at least us mortals now have a way to approach it or to play it in a somewhat, maybe not in its full generality, but try to approach the gods. And I also want to thank Joel very much for organizing the seminar and inviting me here and being very encouraging. And I also want to thank Matthew Boland very much for also helping me very much also with playtesting also just now, and with general thinking about infinite chess. And yes, that's it. Thank you for your attention.
Well, thank you very much. Let's thank the speaker.
Thank you. That was great.
And we're already a bit over, and we had a lot of questions already, but if there are any final questions, then maybe there's time for one or two.
So thank you again very much, Andreas. And maybe, yeah, I mean, in the outlook, you talked about it. Like, I mean, how do you think, I mean, especially after Matthew's results in kind of infinite positions, do you think it's more likely that we should be able to build arbitrarily high game values for finite positions?
I don't want to give away too much, because I have been continuing to work on infinite chess with finitely many pieces together with Matthew very much, and we are both like very excited and eager to do this and also get published and hopefully present good results. So I would say that definitely very, very much is possible. And yes, Matthew's construction, which we will present next, is great, and there is a lot one can do with all this. So yes, definitely, yeah, this is not the upper limit.
Oh, okay. Then yeah, we look forward to hearing that.
Any other questions? Well, let's thank Andreas again then. Thank you so much. And I'd like to invite everyone to come back for the next Infinite Game seminar or workshop on December 7th. Matthew Boland is going to show us that every countable ordinal arises as the game value of an infinite position in infinite chess. And I want to also mention that if anyone's interested in speaking next semester, we're going to continue. And I think we're going to make a fancy website and have a proper mailing list and so on. And I guess we should have done that already, but we're going to have all that for next semester. But if anyone is interested in speaking on further results or other results, then we're going to put together a speaker list for next semester. And so just contact me or Davide or both of us. And okay, I invite everyone back December 7th. Hope to see you then.
Thank you again. Bye-bye.
Bye.